Hello team, my name is Rohit. Today we are gonna little bit discussion about one coding question. This coding question is also related a linked list problem. This is the very most important question, and in this question we have to learn how to delete and remove from linked list. Let's go and watch.
The problem statement is like, given a singly linked list, show whether the list contains a loop or not, and if it exists, then remove the loop. So this is basically a very popular and important question whenever we are talking about linked list. So this is a diagram where you can see this is basically a singly linked list, but a loop exists here. So in this video lecture, we are going to design a program which will be able to detect this loop and which will be able to remove the loop. So if we remove the loop from this singly linked list, the linked list will be 1, 2, 3, 4, 5, and this 5 will point to null, not 2. So 5 will be the last node of the singly linked list. So let's have a look at the approach. So here, what we are going to do for finding the loop in a linked list, we are going to use the Floyd's cycle finding algorithm. For that, we will be using two pointers which will be initialized with the head of the linked list. Let's name them slow and fast. We'll do that. So we will be iterating the list till slow and fast are not null, and in each iteration we will advance the slow pointer by one node and the fast pointer by 2 nodes. Now if at any point in the loop we find that slow and fast, these 2 pointers becomes the same, then at that point we will realize yes, a loop exists, and will return true for loop detection. So if we see this diagram here, we can explain that how it will actually work. Suppose this is the head. Okay, this is the head of the linked list. So at the beginning, slow and fast, both pointers will be assigned with this. So now when the loop starts, first the slow will advance by one node. So in the first iteration we will have 2 as slow, and the fast will advance by 2 nodes. So after first iteration, 3 will be fast. So 2 is slow now, 3 is fast. In the next iteration, 3 will be slow and 5 will be fast. In the next iteration, 4 will be slow and 3 will be fast. And then in the next iteration, 5 will be slow and again 5 will also be fast. So at this point, slow and fast becomes the same node. So we will be able to tell that yes, a loop exists. So now at the point the loop is detected, we'll break the loop, and after coming out of the loop, what we will do is we will start the process to remove the loop. So we will assign the slow with the head again. Now again we will run a loop with the condition while slow next is not equals to fast next, and in the loop we will iterate like at each iteration we will advance both slow and fast by one node. Now after the loop we will get the fast and assign the next field of the fast to null, and this will remove the loop. So if you go back to this diagram, so here at this point we find that slow and fast are equal. So to remove, what we do, we keep fast here and we assign slow with the head again. So now slow is 1, fast is 5. Now we will run a loop to check whether slow next and fast next are not equal. If this condition satisfies, then the loop will run. So in the first iteration we'll see that the next of slow, that is next of 1, is 2, and next of fast, that is next of 5, is also 2. So the loop will not be entered. So we know that this is the node that is fast. We will have to set the next field of this node to null. So we'll break this linkage here from 5 to 2, and this will point to null now. So if we do this, then we will get a singly linked list without a loop, that is 1, 2, 3, 4, 5. So let's now jump on to the programming part and see how we can do it. So I basically have already typed down some lines of codes. It's very basic code for actually creating a singly linked list. What I have done here, I have written a function above here, add node, which will add a single node at each time I'm calling this function. And here we will get 5 as the head of the linked list and 1 as the last node of the singly linked list. Now at this point I'll create a loop here. So what I'm going to do, I'm going to make a loop like the last node of the linked list, that is 1, will point to the second node of the linked list, that is 4. So to do that, we'll first say head next. This is the last node, and this now will point to the second node, right? So a loop has been created now. We will call a function which will detect the loop and remove the loop. So let me name it detect and remove loop, and we'll pass this head of the linked list. After we do that, we will run another loop. Let me just do it right now to check whether the loop has been removed properly or not. While the head is not equals to null, we'll print down the nodes head data separated by a space and head equals to head next. Simple linked list iteration. So now here I am going to define this delete and remove loop function. So the return type will be void, and the argument passed here is struct node star. So here first I'm going to check if head is equals to null or head next is equals to null, then do nothing. So let us say return. It's obviously, if the head is null, then there's no point of having a loop in a linked list, because there's no linked list. And if there's only a single node, then you cannot have a loop. You at least need 2 nodes to have a loop inside a linked list. So if this is not the condition, we have more than 1 nodes in a linked list, then I'll take these 2 pointers. The very conventional way we actually apply the Floyd's cycle finding algorithm. So struct node star, I'm going to name this slow and assign it with the head, and another pointer to the linked list node. I'll name it fast, and again pointing to head. So now I'm going to run a loop here while slow is not null, fast is also not null, and also fast next is also not null. So if I write only slow, it means that slow is not null. So I do not have to explicitly mention slow not equals to null or like that. So if this is the condition, what we do, we advance slow by 1 node, and we advanced fast by 2 nodes. So fast next. And now time to check if there's a loop or not. If slow is equals to fast, then what I'll be doing, I'll simply say break. Now after coming out of this loop, I'll check if slow is equal to fast, then yes, there's a loop exists. Otherwise I'll simply see out no loop found, and then end line. Now here if we see yes that there's a loop, I'll first print down this message, loop detected. Now we're going to remove the loop. For that I'm going to assign the slow pointer with the head and run this while loop while slow next is not equals to fast next, and here I'll advance both of these pointers by 1 node. So slow is equal to slow next, and fast is equal to fast next. And after coming out of this loop, I'll assign this fast next to null, right? So now here the linked list with the removed loop will be printed. So I'll just print down this message. Linked list after loop removal is and an end line. That's it. So let's have another look. Okay, so this is all done, it seems. So let's now run this code. Okay, so here is the output, and you can see it says loop detected. So yes, there's a loop, and the linked list after loop removal is 5, 4, 3, 2, 1, as we had expected. There was a loop from 1 to 4. What we did, we broke that connection between 1 to 4 and told that this node with the value of 1 to point to null, because this is going to be the last node of the linked list, and we printed just like that. So this was a very simple way and an efficient way to detect and remove a loop in a linked list. Thank you for watching this video and staying with us. See you next time.